Hello, everybody. I'm Anthony Liu from AZVR, Mechanical Universe. Today, let's go to the Lesson 6, Center of Gravity and Load Stability in Rigging. Why balance matter as much as strength? Knowing the load, weight is not enough. A safe lift must be strong enough and stable enough. If the center of gravity is ignored, the load can tilt, rotate, swing, or shift. Key idea: a safe lift is about controlling the load. Learning objective. By the end of the lesson, learners should be able to explain the center of gravity in simple rigging terms, recognize why a load may tilt during lifting, understand why the hook should be above the center of gravity, use a test lift to check stability before a full lift. That means stressor is necessary. Stability is also necessary. What is the center of gravity? The point where the load weight can be considered to act. For a simple, uniform object, the CG may be near the geometric center. For an irregular load, the CG may be off center. The CG location controls how the load behaves when lifted. That means CG is not always where the eyes expected it to be. Why load weight alone is not enough? The same load weight can behave very different. Two loads may have the same weight but different CG locations. An off-center CG changes the sling reactions and load balance. The rigging must understand both weight and stability. That means weight answers, how heavy? CG answers, how will it move? Hook position and stability. The hook should be above the center of gravity. When the hook is above the CG, the load tends to hang in a stable position. If the hook is not above the CG, the load may move until it finds balance. This movement can create unexpected force changes. Keywords: hook above CG equals bad control. What happens when CG is off-center? The load may tilt or rotate during lifting. The heavy load drops. One sling may swing or shift as it leaves the ground. The lift becomes harder to control. The key word: unexpected movement is a major rigging hazard. Unequal sling length. Small geometric difference can change the lift. Unequal sling length can pull the load out of the level. Different angles can create unequal sling tensions. The load may rotate until the force balance. That means eco-looking rigging is not always eco-loading rigging. Load stability and sling tension. Stability affects the force distribution. A tighter load may increase the tension in one sling leggers. Dynamic movement can add extra load beyond static calculations. A stable load reduces the sudden change in force. Keywords: stable geometry supports the safe force distribution. The test lifting. Lift a small distance, then stop the check. Raise the load only slightly from the ground. Here is yellow means ground. Check whether the load is level and stable. Check sling angles. Attachment points, and load movement. Lower and correct the rigging if anything looks wrong. To sum up, never rush from setup directly to full lift. Practical safety checklist. Before the full lift, ask these questions. Do we know the load weight? Do we know or estimate the CG location? Is the hook above the CG? Are the sling lengths and angles appropriate? Did the test lift confirm stability? That means if the answer is unconcerned, stop and reassess. Common mistakes. Many riggings in accidents begins with simple assumptions, assuming the CG is at the center, ignoring hidden weight distribution inside the load, lifting too quickly without a test lift, focusing only on sling capacity, not load control. To sum up, the danger word in rigging is assume. Key takeaways. Center of gravity is a safety concept, not only a mass concept. A safe lift requires weight knowledge, proper geometry, and load control. The hook should be above CG whenever possible. A test lifter is essential for confirming stability. In rigging, unpredictability is danger. To sum up, a safe lifter is not only about lifting, it is about control. That's all for today. See you next time.